Hello students, so we are at the end of this binary operation chapter. So we are going to solve few problems related to that commutative, associative, identity and inverse. Okay, so the question is, let star be the binary operation on n given by a star b is equal to a star b is equal to LCM, least common multiple of a and b or two numbers. We have to find out, okay, first one, what is the LCM of 20 and 16, and we have to check whether it is commutative or not, associative or not, and as well as we have to find out the identity element of the binary operation star on set of all natural numbers. So first question is, find LCM of 20, 16. See, common multiple 20 and 16, and in which you have to find out the least one. Okay, which is the least common multiple between these two? See, 20. What are the multiples of 20? 20, 40 and so on. 16 are the Stella 16, 32 and so on. So which is the least common multiple? 80. 16 5s are 20 4s are. So the least common multiple of 20 and 16 is 80. So LCM of 20 and 16 is 80. I hope you understood. So this is simple. You already did this type of work in a lower class. So 20 star 16 andre a least common multiple of 20 and 16, which is equal to 80. Okay, what is the next work? The next work is star is commutative. Is star commutative. So we have to check that whether a star b is equal to b star a. What is a star b? LCM of a comma b. A star b is LCM of a comma b. So what is b star a? It is nothing but LCM of b comma a. Now whether these two are equal, can we say that LCM of b comma a is LCM of a comma b? Yes. Right? No, LCM of 20 comma 16 or 16 comma 20, one and the same, which is 80. So therefore star is commutative. Therefore star is commutative. Next question is, star is associative. We have to check whether it is associative or not. This is the third question, whether star is associative or not. Okay, so ಯಾವ್ದನ್ನ ಚೆಕ್ ಮಾಡಬೇಕು? A star b, okay, star c equal to a star b star c. We have to check that. Okay, so now first find out b star c. What do you mean by b star c? LCM of b comma c, correct? Now what do you mean by a star LCM of b comma c? It is LCM of a comma LCM of b comma c, correct? A and b, right? Now this is also equivalent to LCM of a comma b comma c. You can check this. You know about this because in lower class you studied about least common multiple in detail. So you know about this. If you want to check, you take some examples for ABC and check whether it is true or not. And it is true. Remember that. Okay. So we can prove that a star b star c is equal to LCM of a comma b comma c. One part is over. Okay. Now we have to check the another one. What is another one? A star b star c. That is LCM of a comma b star c. Okay, LCM of a comma b star c. See, now this is also equal to LCM of a comma b comma c. That is LCM of, as I told in the previous work, it is also equal to LCM of a comma b comma c. So a star b star c is like this, and because of this definitely you can write a star b star c is equal to a star b star c. So what is the conclusion? Therefore star is associative. Therefore star is associative. I hope you understood. Please check this, okay, once. Okay, not this is okay, fine, not an issue. This you check once, okay, by taking some example. Illinda illige artha agilladre ಒಂದು example ತಗೊಂಡು check ಮಾಡಿ. Otherwise this part is very simple. Okay, so already 3 problems solved. The fourth one we have to solve, which is find the identity of star. Identity element we have to find out. So to solve the next question, you assume one element as an identity element. Okay, let E be an identity element. Be an identity element. Let E be an identity element. Okay, this is we are assuming, remember that. Suppose this is an identity element. By the definition of identity property, A star E is equal to E star A is equal to A, right? A star E is equal to E star A is equal to A. Okay, so now just take this part. A star E is equal to A. Just take this part. A star E is equal to A. Now what does this implies? LCM of A comma E is equal to A. Now this implies, can you tell me what is E? E must be is equal to 1, because only 1 is possible for all such A which gives A itself. So, and is it E 1 belongs to N? Therefore, yes, 1 belongs to N. Therefore, identity element, okay, identity element is 1 and it belongs to N. So, identity property also holds. So, in cases of this particular problem. Very good. Next question. So, one more different special problem in commutative and associative. Here, binary operation of this kind: A star B star C comma D is equal to A plus C comma B plus D. See here, set is N cross N. Observe what is some changes. Okay, as I told, this is one different and the special question. So observe carefully. Here, elements are in the form of ordered pairs. Elements are in the form of ordered pairs. We have to check whether it is commutative or not, associative or not, as well as if identity exists, find out. Okay, so let me check first whether it is commutative or not. Okay, first check whether it is commutative or not. Okay, take two elements belongs to the set. Okay, or you can take like this also, not an issue. A comma B star C comma D. Okay, you take the one A star B like this. According to the definition, it is A plus C comma B plus D. Correct? Now, ulta bari commutative ade alva C comma D star A comma B enagate C plus A comma D plus B. Correct? So this is also equal to this is also equal to A plus C comma B plus D, and this is nothing but A comma B star C comma D. So therefore, what is the conclusion? Therefore, star is commutative. Therefore, star is commutative. Correct? I hope you understood. Therefore, star is commutative. Okay. The next work. Okay, we have to check whether it is associative or not. Okay. So we need here three order pair. Okay, one is, let it be A comma B star C comma D. Okay, star E comma F, and take in the different pattern. First, let me consider this. So A comma B hage irate star. If you apply the binary operation star here, it will be C plus E comma D plus F. Correct? Again apply same binary operation, you get A plus C plus E comma B plus D plus F. So this is, let it be one part item. Next, A comma B star C comma D kill bracket haki star E comma F. So this will be A plus C comma B plus D star E comma F. Again apply same binary operation, A plus C plus E comma B plus D plus F. Compare 1 and 2. What is the conclusion? From 1 and 2 in barate, from 1 and 2 star satisfy this property, A star B star C equal to A star B star C. So if this condition satisfies, we can write that star is what? Associative. We can prove very easily this is associative. The next question is find the identity element of the function. So third one, you have to find out the identity if it exists, right? So let us assume that x comma y be an identity element. Be an identity element. Consider an identity element as x comma y. Then according to definition, A comma B star x comma y must be is equal to A comma B. Now we have to check whether this x comma y is virtually exists or not. Okay, now if A comma B star x comma y implies what? A plus x comma B plus y is equal to A plus B. So this implies what you will get? A plus x is equal to A, B plus y is equal to B. So this implies x is equal to 0 and y is equal to also 0, because cancel agatalva. So this implies you will get x comma y is nothing but equal to 0 comma 0. Okay, this is the identity element. But is it this identity element is belongs to n cross n? Set is n cross n. No, A is nothing but n cross n. Is it belongs to n cross n? Definitely no. The reason is 0 does not belongs to n. Remember that. Since 0 does not belongs to n, 0 comma n, 0 comma 0 does not belongs to n cross n. Identity element exists, but it is not exist in the set. So what is the conclusion? Therefore, identity element does not exist. Identity element does not does not exist in A, okay, with respect to the binary operation star. So this is the conclusion for the last part of this question. So in this question we had three parts. One is commutative, another one is associative, and last one we have to check whether identity element exists or not, and we are able to prove that identity element does not exist. Understood? So okay, the last concept of relation function, it's called binary operation table. Binary operation table. Very simple concept. Okay, 1 mark ki baro chance the 2 marks ki baro. Simple concept, binary operation table. Okay, so I'll explain in general. So if I take a set G like this, A1 comma A2 comma A3, okay, let it be 3 elements, and okay, and the binary operation is star. Then I'll show you how to write the binary operation table. Okay, binary operation table will be as follows. First you have to write one table. Table means what? Rows and columns. You have to write rows and columns. List element is 3 elements. So first number of columns A1, A2, A3. Here all same number of rows. Here the binary operation. Complete the table. Okay. A1 star A1. Whatever it may be, star may be anything, addition, subtraction, multiplication, division, it can be anything, but fill it here. This position will be A1 star A2, this is A1 star A3, like this you are going to fill it. A2 star A1, A2 star A2, okay, you are going to multiply the elements and you are going to fill the table like this. Only you should know how to fill the table. It has a lot of application, maybe not there in a syllabus, or okay, all the application of this binary operation. Okay, let me take one simple example for this binary operation. For example, okay, if set A is equal to 1 comma 2 comma 3 and the binary operation is addition, then what is the binary operation table? Binary operation table will be as follows. 3 elements there, 3 columns and 3 rows, except the first one. Illi en baridu plus illi elements 1 2 3 1 2 3. How to fill the elements? 1 into 1, 1 into 2, 1 into 3, 2 into 1, 2 into 2, 2 into 3, 3 into 1, 3 into 2, 3 into 3. Ig fill ಮಾಡಿ ಬಿಡೋದು ಅಷ್ಟೇ. So based on this we are going to solve two problems, very simple two problems, okay, using the binary operation concept. Some properties are there, okay, I'll just explain in that problem only, but in detail it is not there in the syllabus. Okay, the first problem using the concept of binary operation is, consider a binary operation star anta tagoltevili, like, okay, just for change we are in like a symbol of this kind, okay, instead of star. That's it. Again, confusion illa. On the set A is equal to 1 comma 2 comma 3 comma 4 comma 5, and they asked to write the binary operation table where the star or the cap or star is defined by A cap B equal to minimum of A and B. So they are asking write one binary operation table. Simple, that's it. See this, write this position for the binary operation and the remaining position for the elements 1 2 3 4 5, 1 2 3 4 5. Now we have to fill this table, okay, using the binary operation, minimum of A and B, minimum of A and B. So you have to fill this table, that's it. Yeah, minimum of A and B you have to write in this box. What is the minimum of 1 and 1? 1 itself. Minimum of 2 and 1? 1. Minimum of 1 and 3? 1. 1. 1. No confusion. Okay? Because in this list the least value is 1. Minimum between 2 and 1 is again 1. Minimum between 2 and 2, it's 2 itself. 2 and 3, 2. Minimum of 2 and 4, 2. Minimum of 2 and 5, 2. 3 and 1, 1. 3 and 2 only 2. 3 and 3, 3. Minimum of 3 and 4, 3. And next 2 is 3 only. The next column, 1, 2, 3, 4, again 4. 1, 2, 3, 4, 5. That's it. This is for 2 marks. So very easily you can fill this table, okay, using this binary operation, minimum of A and B. The answer is like this. Did you observe? Very good. The last question for this chapter, which is using binary operation, is as follows. Consider a binary operation star on the set 1, 2, 3, 4, 5 given by the following table. Here binary operation is not mentioned properly, but instead of that they given one very important, okay, which is a binary operation table. So everything is mentioned, only you have to solve 3 problems. Okay, the first question, compute 2 star 3 star 4. Okay, so to find out this, use this binary operation table. 2 star 3, and I know which table is 2, which box is 2 star 3 here. 2 star 3, this is a table box which contain the output of 2 star 3. So it is nothing but 1 star 4. Now where is a 1 star for 1 star 4? So this is a box for 1 star 4. What is the output of that? 1. So it is, answer is 1. 1 star 4 is equal to 1. Observe ಮಾಡಿದ್ರಲ್ವಾ? 2 star 3. So this is a box. 1 star 4. This is a box. Okay? Yes. Next question is E star commutative. Commutative means what? A star B is equal to B star A. Okay. Example is not answer, but let me explain this with an example. 2 star 3. 2 star 3 is 1. Okay, already it's there in a board. Where is 3 star 2? This is the 3 star 2. What is 3 star 2? Tell me. Is also 1 only. You can observe that in a table. So yeah, 1 almost confirm that it is commutative. But in general, how to write? You can't give examples for all, right? So if this table is symmetric about the principal diagonal, this is a principal diagonal, then this diagonal is called principal diagonal. If this table is symmetric about the principal diagonal, then definitely you can say it is commutative. Check ಮಾಡಿ. Symmetric andre no, see, this elements are same, this is same, here also same, right? I hope you can observe this position is also same. See, this is 2, this is 1, this is 1, right? So this table is symmetric about the principal diagonal. You should write this. Table is symmetric with respect to principal diagonal. So, therefore it is commutative. Therefore answer is, yes, this is the reason. Idu baribekantiಲ್ಲ. Okay, you just write that this is a symmetric. This table is symmetric about the principal diagonal. So answer is S. Yes, it is commutative. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? Very good. Last one, the last problem of this chapter, compute 2 star 3 star 4 star 5. Okay, 2 star 3 already ನಾನು ಬರ್ದಿದ್ದೇನೆ ಬೋರ್ಡ್ ಅಲ್ಲಿ, that is 1. 4 star 5 ಅಲ್ಲಿ ಬರುತ್ತೆ 4 star 5. So that you will get here, right? This is a 4 star 5. Even that is also equal to 1. 1 star 1 is easily visible, and that is equal to 1. ಅರ್ಥ ಆಯ್ತಾ? So we completed one more important chapter called relation function, as well as one small topic which is included in that, binary operation functions. Okay, so we completed this chapter. Remember, already we completed relation function, matrices over in the vacation, in the beginning only. Differentiation is over. Okay, so continuity is over. So next topic, okay, for this online classes is application of derivatives. Artha aita? Thank you.